So we are seeing a high degree of variability among sites. We are seeing a high degree of variability among individuals within sites. So that may be important in explaining why we see such variability in disease prevalence throughout the islands. So the last question, or the last objective we had, was to look at differences in antimicrobial activity and chemical constituents between healthy and diseased corals. And we were working with Montipora, which in Kaneohe Bay at least is susceptible to Montipora white syndrome, which is Greta is now following up on. And we looked at the diseased tissue on the diseased corals, the healthy tissue on the diseased corals, and nearest neighbor healthy colonies, and that was our control tissue. And so we had a couple of different comparisons. We were interested in the control tissue versus the healthy tissue on the diseased coral, and our question was whether the control corals have higher levels of antimicrobial activity that might prevent that coral or reduce the susceptibility of that coral to getting the disease, even though its neighbor did have the disease. And then we looked at the diseased tissue and compared it to the healthy tissue on the same coral. And the reasoning there was that the diseased tissue might have induced levels of antimicrobial activity or increased its levels of antimicrobial activity relative to other parts of the colony in order to fight off that bacterial infection. So we performed growth assays again, and this is just a little different way of looking at it. These are the slopes of the growth curves. So the more negative the slope, the more inhibitory the assay or the extract. And so what we're looking at here is the control coral compared to the healthy tissue on the diseased coral. And in the case of Yersinia, there was a significantly greater level of antimicrobial activity in the control coral than in the healthy coral. And although it's not significant, several other bacterial strains we found a trend towards similar effects. So it does appear that control corals may have higher levels of antimicrobial activity overall that may play a role in protecting them from disease. We then compared the diseased tissue and the healthy tissue on the diseased corals, and here we see that the diseased corals have higher levels of antimicrobial activity than the healthy corals, at least against Erantomonas corallicida, and again we do see a trend towards a similar effect against several of the other bacterial strains. And this suggests that there may be induction of antimicrobial defenses in the diseased tissues. So the next question was whether this is manifested or whether we can see this by looking at the chemistry of the corals. And so we made chemical fingerprints, which is just a way of visualizing what's in these extracts, because the extracts are basically this tarry substance at the bottom of the vial, and you don't know exactly what's in it. So we injected our extracts into an HPLC, which is a chromatography system that allows you to separate the individual components of a complex mixture. So each of these peaks represents an individual chemical molecule. And we compared the areas under the peaks for each peak in the different spectra of our different corals to see whether we can detect any differences. And so overall, the spectra that we've got from all of our corals were relatively consistent. And this is good because these are the same species of corals at the same site. So you would expect a high degree of consistency. But we do have a few peaks that show differences. Peaks 7 and 14 had higher levels of higher levels of those peaks in the control corals compared to the healthy corals. And peak 15, which is this one here, showed a trend towards that direction as well. So this is in concurrence with the fact that we're seeing higher levels of antimicrobial activity in the control corals than the healthy tissues on the disease corals. And for those same peaks, we're seeing a trend towards higher levels of those particular compounds in the diseased tissue than in the healthy tissue, which again is supportive of the possibility that these are inducing defenses in response to the pathogen. So in conclusion, Hawaiian corals do have high levels of antimicrobial activity. It is highly selective for different types of bacteria, and that's important because corals should have, or naturally do have, their own bacterial community associated with them. So they don't want to just kill off everything. They want to be able to have a natural bacterial community. And so they are selective against certain bacteria and not others. And in some cases, they have stimulatory effects on bacteria, which can encourage the natural bacterial community to grow. We found variability among oral genera, among the 3 sites, and among individual colonies within species and sites, which probably goes a long way towards explaining the patterns that Greta and others have seen in the field when they've done disease surveys. When we looked at Montefiore-White syndrome, we found that healthy colonies have the healthy control colonies have higher levels of antimicrobial activity than their diseased counterparts, and that this is more impressive towards some bacteria than towards others. So again, there's selectivity. Diseased colonies do tend to have higher levels of antimicrobial activity in the diseased tissues, suggesting that there may be an induction of defenses to try and fight off that pathogen. And the differences in the chemical profiles reflect this variation in defense. So this was basically an initial study. As I mentioned, there was nothing known about antimicrobial activity in Hawaiian corals, and there's clearly a lot of interesting patterns here, and we feel that a better understanding of these patterns would go a long way towards helping us understand resistance and susceptibility of coral to disease, and where you might be able to predict patterns of disease prevalence.